Okay, so we start with a little bit of a review. We're going to be looking at linear, rational, and absolute value equations. One of our main goals in algebra is to develop techniques for solving a wide variety of equations. In this section, we will solve linear equations and other similar equations. So again, we see that word solve. Anytime we're solving something, we're trying to get the variable by itself. So that worksheet you did all last week was all about expressions. They were things without equal signs and how you factored them. Well, now we're going to be solving equations. So they're going to have an equal sign, and we're going to want to get the variable by itself. So this first equation, does anybody know what we call this? I say it a lot of times in 8th grade. Well, they are ratios because they are fractions. But when we have two ratios equal to one another, that is called a
What's it start with?
a P.
I feel like I know it, but I don't know
I don't know if I'm spelling it right.
it. Proportion.
Yes. Proportion, a fraction equal to a fraction. And it may not be an O, now that I think about it. Maybe any I can't remember. Okay, so a proportion is a fraction equal to a fraction. So anytime you have a fraction equal to a fraction, how do we begin to solve those? There's one step that's very common for all proportions. Fraction equal to a fraction, we cross multiply and set those two things equal to each other. So I have x plus 3 times x plus 6, and that's going to be equal to x plus 2 times x minus 5. Now we've got two parentheses being multiplied by each other, so we distribute. X times x is x squared. X times 6 is 6x. That green's terrible. Let me change. X times x is x squared. X times 6 is, why did I put this? X squared. X times 6 is 6x. 3 times x is 3x. 3 times 6 is 18. Equals, same thing here, distribute. X times x is x squared. X times negative 5 is negative 5x. 2 times x is positive 2x. And then 2 times negative 5 is negative 10. Now combine our like terms. 6x plus 3x gives 9x. Negative 5x plus 2x gives negative 3x. And so we are solving this equation. So our goal is to get the variable by itself. Well, I have variables all over the place, right? I have an x squared and an x on the left. I have an x squared and negative 3x on the right. So what we always want to do is get everything that has a variable to the same side. If it doesn't have a variable, get it to the other side. So I'm going to move the x squared and the negative 3x to the left, and I'm going to move the positive 18 to the right. Is that the way y'all are used to talking about it, moving them instead of adding and subtracting? Okay, so that's what I'm going to do. So I move those to the left, I move that to the right. So that's going to give me, I still got the x squared plus 9x. I'm going to move over an x squared, it becomes negative. I'm going to move over a negative 3x, it becomes positive. Now I've got a negative 10, I move 18 over and it becomes negative.
Wait, so you just moved all the variables on the right side over?
Yes. Get all the variables to the same side. Okay, now combine them. Do I have anything that is like x squared? A negative x squared. So what is x squared minus x squared? 0. That term's gone. Next, I have a 9x. Do I have anything like 9x? 3x. 9x plus 3x is 12x. So that's everything on the left side. Now on the right, I've got a negative 10 and a negative 18. Those combine to give negative 28. Now, x is being multiplied by 12, so I'm going to divide by 12. That tells me x is equal to negative 2.5. No. Negative 2.3 repeating, or negative 7/3. What? It's still early in the morning. That was some bad math to start with. Okay, so what makes this one a little bit different? We've got a fraction on the left, a fraction on the right that are equal to each other, but there's this constant term that is not exactly what we would want to deal with. So there's a couple of ways we could solve this, but here's what I think would be the easiest here. Because they already have a common denominator of y minus 3, I'm going to get those fractions to the same side because it'll be easy to combine them. The thing that does not have a fraction, we'll move it to the right. Okay, so I'm going to move this to the left side, and I'm going to move the 3 to the right side. So that's going to be y over y minus 3 equals, nope, minus 3 over y minus 3 equals negative 3. Now go ahead and combine those fractions. They have a common denominator, so we just combine the numerators. So the numerator says y minus 3. So that gives y minus 3 over common denominator y minus 3 equals negative 3. That makes absolutely no sense. Okay, so this is where we got to, right? Does everybody follow where we're at?
How did you get the y minus 3 over the other y minus 3?
This?
Yeah, how'd you get that?
Well, because I'm subtracting fractions.
Okay, I didn't know if you realized. Sorry, I was dumb.
So it's y minus 3. They had a common denominator of y minus 3. So I kept that. Now I've got a fraction equal to negative 3. So I would put this over 1. Now I've got y minus 3 over y minus 3 equals negative 3 over 1. I cross multiply. So that's going to give me negative 3 times y minus 3 equals y minus 3 times 1. Now I distribute. That's going to give negative 3y plus 9 equals y minus 3. Now get your y's to one side, get your numbers to the other. So I'm moving this to the left, I'm moving 9 to the right. Negative 3y minus y equals negative 3 minus 9. So that's negative 4y equals negative 12. Now I'm going to divide by negative 4. And that tells me y has to be equal to 3. Problem. So y equals 3. That's real nice. All right, we're all finished. No, we're not. Look at my original problem. What happens if I plug in a 3? Do I get two things that are equal? Why not? If I plug in 3 here, that gives me 3 over 3 minus 3. No. This would be 3 over 0. No. That's why I said what a lovely problem early on. Now, I've just looked at the video of the people that made these problems, and they acted like it was right, that 3 was the answer, but it can't be. Okay? So, yeah, but I'm posting this to the internet, and they might hear the answer.
they can still hear you if you whisper.
Oh, good point. Okay, so I don't know what they really wanted us to accomplish with this problem. The correct answer here would be there is no solution. There's nothing that works. And do you see why? Anytime you're dealing with a rational function that's, a fraction, you always need to plug in to make sure this doesn't happen. I wish I'd done that on the last problem, now that I think about it. But that was such an ugly number, there's no way that was going to make the bottom zero. Okay, but here, 3 working is not good. And here is how I caught on. So I didn't go ahead and solve it and plug in 3. When I looked at the problem, I had y minus 3 over y minus 3 equals negative 3. Well, what is y minus 3 over y minus 3? That's 1. So I saw 1 equals negative 3. Well, I knew that's not good, okay? That there was something up. So that kind of gave me a hint, hey, you might want to go plug your answer back in, make sure it works. And it didn't, so it should be no solution. Now I've got 1 over x minus 1 minus 1 over x plus 1 equals 2 over x squared minus 1. So now I've got a fraction on the right side, and I have 2 fractions being subtracted on the left side. So it's not going to combine as easily as the last problem because I do not have a common denominator. Everybody see that? How it's going to be different. And getting this fraction over there is just going to complicate things even more because it's its own denominator. It's different from those anyways. Well, it is. We could go through, but that's not really going to help us this time. You could write this as x plus 1, x minus 1. But our goal is to get a common denominator to have as few fractions as possible. You see where so it's not going to necessarily help. Now, what I do want to do, on the left side, we are subtracting fractions. If I can get a common denominator, then I can combine those over a single fraction. And then I will have a fraction equal to a fraction that I can cross multiply and set equal. It's the way I'm heading. So, what would be my common denominator between x minus 1 and x plus 1? Do you know how you find the common denominator? If my denominators were 4 and 3, what's the common denominator? Okay, so with numbers, you got no problem. How did you know it was 12? So you multiply the 2 denominators by each other to find the common denominator. Same thing. Okay? I need to multiply x minus 1 times x plus 1 to get a common denominator. So we know our new denominator is going to be x minus 1 times x plus 1. It's going to be those 2 denominators multiplied together. Now we got to go back and ask ourselves a question. How could I get from x minus 1 to x minus 1 times x plus 1? Well, I would need to multiply this fraction by x plus 1 over x plus 1. So what is it I'm actually doing? I'm multiplying the denominator here by x plus 1 to make it match our common denominator. But by multiplying by x plus 1 over x plus 1, I'm really only multiplying by 1. So that's not changing the number. I'm keeping it the exact same number because when we multiply by 1, it does nothing to the number. I'm just changing the form that it looks like. Okay, so now then, in the numerator, I've got to do 1 times x plus 1. Well, 1 times x plus 1 is x plus 1. And then the denominator, x plus 1 times x minus 1 is x plus 1 times x minus 1. That's what we got from before. Now, on the other fraction, it has a denominator of x plus 1. I need it to be x minus 1 times x plus 1, so I need to multiply by x minus 1 in the numerator and denominator. Now what we have to be more careful about in this fraction is this subtraction sign. this whole fraction is being subtracted. So I just got to be aware of that when I start writing what's left over. So the denominator is pretty simple. X plus 1 times x minus 1 gives x plus 1 times x minus 1. Now this is a negative 1 times x minus 1. So when I distribute, negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. And that should be equal to 2 over x squared minus 1. So now I've got an x minus an x is 0. 1 plus 1 is 2 over x minus 1 times x plus 1 equals 2 over x squared minus 1. So some of you may already be able to tell, well, this is the exact same thing as this. So I'm showing two things are exactly equal, and they're in the exact same form. Well, all right, what if you didn't notice that? Okay, well, let's just pretend we didn't notice, and we would continue with the problem. Fraction equal to a fraction, we would cross multiply. So that's 2 times x squared minus 1 equals 2 times x minus 1 times x plus 1. And now we distribute. So that would be 2x squared minus 2 equals, now over here I'm going to multiply the parentheses first. So I'm going to leave the 2 alone for now. That's going to be 2 times x squared plus x minus x is gone. 1 times negative 1 is negative 1. And now we distribute the 2, so that gives 2x squared minus 2 equals 2x squared minus 2. Now I would want to get my variables to one side, the numbers to the other. So I'm going to move 2x squared to the left. I'm going to move negative 2 to the right. So this becomes 2x squared minus 2x squared equals positive 2 minus 2. So that gives 0 is equal to 0, which is a true statement, right? Remember the last problem I saw 1 was equal to negative 3 was what I saw happening. But here I'm getting 0 equals 0, which is a true statement. So what's the answer when your variables go away and you get 0 equals 0? All real numbers should be the answer. Okay, but this one has a caveat because what was I working with to start with? I was working with rational functions, which means all real numbers could work, but I still can't divide by 0. So if I plug in something that makes me divide by 0, that should not be an answer. Okay, so what numbers could I plug in that would give me a problem that would make me divide by 0? If I plugged in 1, that would break this fraction. If I plugged in negative 1, that would break this fraction. This one, if I plugged in 1, it breaks. If I plugged in negative 1, it breaks. So I could plug in anything I want besides 1 or negative 1. So my answer is all real numbers except 1 and negative 1. And we'll go over, there's a little bit fancier way we can write that. So let's pretend like we had to put it in a certain kind of notation. Yeah, let's just go ahead and do that now because it's coming. Okay, so what's the smallest number that I could plug in that would work? Nope. I could plug in something smaller than that. So if I had to show this as all real numbers except 1 and negative 1, here is one way we could show that. So we could say from negative infinity up until 1. I'm sorry, negative 1 should be first. So we're going from negative infinity up to negative 1. Our x can be any of those things between negative infinity and negative 1. So you read that as negative infinity is less than x is less than negative 1. Okay, what's the next section? Well, it could be anything between negative 1 and 1. So we would say, or x could be between negative 1 and 1. So negative 1 is less than x is less than 1. Or the top one, it could be greater than 1. So 1 would be less than x, which is less than infinity. Okay, this is the way that am used to writing it. When I taught Precal on its own, this is the way I would answer that. But if you take Math 112 and you're going to take it on the computer, they use what's called interval notation. So another way to write this, okay, is from negative infinity to negative 1, from negative 1 to 1, and from 1 to infinity. But you have to put unions. I forgot that. So it would be negative infinity to negative 1, union, negative 1 to 1, union, 1 to infinity. Yes, a big capital U. The union. That means you join those together. Now, the reason that I usually don't teach interval notation, or didn't, is because what if your interval is something like this? Well, what does that look like if that was on its own? That looks like an ordered pair, okay? And so I didn't like people get confused. So I just didn't even talk about it. But now that I've seen the way Northeast does it and they use it, I'm going to go ahead and start using it because it'll help you get used to it. Here's the way interval notation works. If it's less than or greater than, you use parentheses. If it's less than or equal to or greater than or equal to, you use brackets. Braces. Bracket. No, that's a bracket. Use brackets.